Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is Maximal Score after applying K operations. The problem statement goes like this. You will be given a zero indexed integer array nums, and an integer k will also be given to you, and you will be starting with a score of 0, and in one operation you can choose any of the indices of the given nums array and increase your score value by the value that is present at that particular index inside the nums array. Okay, and then you will be replacing that value by the ceiling of that value divided by 3. Okay, so then you have to return the maximum possible score which you can attain by exactly applying k such operations. Okay, the operation that is being described above. And the ceiling, if you do not know it prior, the ceiling function is the least integer greater than or equal to the value. Okay, the ceiling of a value is the least integer that is greater than or equal to a particular value. Okay, so then let's have a quick look at the constraints before thinking of an approach. So according to the constraints, the length of the nums array is of order 10 is to power 5, and each of these entries in the nums array will be of order 10 raised to power 9. Okay, and k will be of the same order as that will be the length of the nums array. Okay, so let's quickly think of an approach. So see, consider that you are given some values in the nums array. Okay, and let's take the very first example that we were given, 5 tenths and k is equal to 5. Okay, so and k is equal to 5, so you can do the operation 5 times. Okay, so we must be choosing only those entries which will be giving us the maximum boost to our score value. Okay, initially you will be starting with a score value of 0. Okay, so let's say there is a magic box. So if you put some entries inside it, okay, let's say while traversing this array from left to right direction and checking its values one by one, so you inserted these 10 fives, 5 tens into this particular box. Okay, now what this particular box will do is, let's say you are asking this box what is the uh, entry which will give me the maximum boost to my score value. Okay, so it will always give you that value. Okay, so this magical box functionality is implemented with the help of, we will be implementing with the help of a data structure called heap. Okay, so if you are not familiar with it and you are hearing this term for the very first time, then I will be providing link of an article describing what heap is and how and when to use it and some basic things on it. Okay, so essentially heaps are of two types, min heap and max heap. So as the name suggests, the min heap will always return you the minimum possible value that will be contributing uh, always. Okay, and the maximum heap will be always returning you the maximum possible value. Okay, so if you are interested in learning more about it, and I would also recommend it, that you should be having a good understanding of heap. So head over to the link in the description box and please read that article and come back to the problem statement, this problem particular video. Okay, and then uh, this particular box will be returning you 10 as of now. Okay, so then what you have to do is you have to essentially replace this 10. Okay, let's say you take out 110 and this is gone, and you will be taking this value and adding it again to the box. Okay, and the it is the headache of the box that how it will be keeping those values so that it always gives you the maximum possible contribution to your score value. Okay, so uh, now the question arises that how you will be calculating this value easily. So for that, what we will be doing here is we will be using our formula. When these two values, with the value on this side and this side, let's say it is something like this. Okay, when value and d, the thing that is dividing the value, are both positive integers, then this particular ceiling of this particular will be equal to value plus d minus 1, this whole divided by d. Okay, so if there is any remainder of just dividing this value by d, then what this particular thing does is it shifts it to the next quotient. Okay, for example, let's say there was 5 divided by 3. Okay, so here d is 3, and you will be doing 3 minus 1 and it will be 2. Okay, so see, it will be 7. So when you do a integer division of it, it will be 2. Otherwise, if you have divided 5, just 5 by 3, it would have been 1. Okay, so it shifts it to the next possible integer value. Okay, and if let's say there is a value that is completely divisible by 3, in that case let's say it is 6, and then you will be adding 3 minus 1 2, and this whole divided by 3. So see, it is not still equal to 9, so you will still be getting this 2 only. Okay, so it will be 8 divided by 3 and it will result into 2. So it only shifts the quotient to the next integer only when there is some remainder, when you divide the actual value by t. Okay, so we will be using this kind of formula, and each time we take something out of this magical box, we will replace it with this particular value. Okay, this value we will be replacing it with, and then we will be again adding it to the magical box, you can say. Okay, so let's see how we have implemented this approach. For that, I will be taking the code to the board, and let's take a let me take the code first, and let's begin with the new slide. Okay, so this is the code. I hope it's visible enough for you. So what we are doing here is, first of all, we are using this max score queue as a magical box. Okay, essentially it is max heap. Okay, always giving out you maximum value. Okay, by arranging it somehow. So then you will be first of all adding all the values that were available to you in the nums array to this magical box. Then once it is having all those values, you will be initializing your maximum score with 0 as mentioned in the problem statement. Then you will be doing k-such operations that were described in the problem statement. So what you will be doing is, one by one you will at each operation taking something out of the magical box. Okay, and that will be your contribution, so you will be adding that to your score. Now comes the replacement part. So you will replace that value that you have just taken out with its this particular value, ceiling of value divided by 3. Okay, so as mentioned, so 3 here is d, and so 2 will be d minus 1, which will be 3 minus 1 is equal to 2. Okay, so it will help you to find out this particular value for each contribution, and then your maximum contribution will be having a new value. And if it is if it is 0, then there is no point of using it because it will not increase your score. And if it is greater than 0, then you will add it back to the magical box. Okay, or the max heap. Okay, and you will be doing k such operations, and once you have done all those, your maximum score will be your answer. Okay, which you will be returning. Okay, so if we talk about the time complexity, The time complexity wise, this particular insertion and taking out of values take log of n, where let's say n is the size of the nums array. Okay, and if you are doing n such operations, if you are having n such elements, those are taken out in and out of the magical box, so it will take you order of n log of n. Okay, and even in this particular thing will also be taking n log of n, because each insertion is log of n, and if there are n entries, it will be order of n log n. Okay, and space complexity wise, at this particular moment all the entries, n entries will be there in the magical box, so it will be order of n. Okay, so these will be the complexities, and this is the approach and implementation. If you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. I really hope this solution walkthrough added some value to your journey of honing your DSA skills. Keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.